So this review video is about fractions, improper fractions, mixed numbers, and kind of simplifying fractions to get equal numbers. So if I look at this diagram I have, so I have a half of a circle. I think that you can see that pretty easily. I can see that a half of a circle is the same as 2/4. So here's a fourth plus a fourth and equals 2/4. That's the same as 1/2. I can even overlap those and see that that's exactly the same. Okay. I can also see that 1/2 is the same as 3/6. 1/6 plus 2/6 plus 3/6. I can see that those are the same. I can also see that 1/2 is the same as 5/10. So if I have 1, 2, 3, 4, 5/10. So I can see that those are the same, which I probably already knew, but I can see that a little bit more clearly. I can also see on something like this. So if I have 1/6 and 1/12, these are the exact same. I can see that 2/12 is the same as 1/6. So these are the same amount. I can see that they're kind of interchangeable when I pop them off. Okay, so these are useful because they also show the decimal equivalent and they show the percent equivalent. So on all of these. When I think about mixed numbers, it might be a little bit harder to convert between them, but I should be able to convert pretty easily. So I'm going to use not necessarily these fraction circles that I just showed you, but some other fraction circles. So if I look at the number, let's go with 3 and 2/3, for instance. So I can look at that using fraction bars. So I have, if this is 1 whole, 1, 2, 3, and 2/3. And I can kind of continue those third marks throughout everything. What I'm doing when I convert to an improper fraction is I'm trying to see how many thirds total there are. And improper fractions are not bad. They're not wrong. They're not incorrect. They are just fractions that are greater than 1. So 3 and 2/3, greater than 1. So a lot of fractions are less than 1, but those are not the only fractions I use. I use lots and lots and lots of fractions that are bigger than 1. So I need to be able to work with those numbers, and often improper fractions are a better way of working with those numbers than mixed numbers. So I'm going to go ahead and count up how many thirds I can see. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You might have noticed as I was counting that I could have just counted in groups of 3. So I could count, this is 3, this is 6, this is 9, plus 2 more equals 11, which is why that trick of multiplying by the denominator times the large whole number makes sense, because what I'm doing is I'm just counting in those groups a little bit faster. So I'm just trying to speed up the process. That's the only reason. Drawing a picture is totally valid. It just takes me a little bit longer, but it doesn't mean it's bad. I can draw a picture for everything. So 3 times 3 is 9, and then plus 2 is 11. So that's how I get that procedure, is by doing something like this. If I didn't like fraction bars, it's the exact same thing if I do circles. So if I have 1, 2, 3, 4 circles, so that I can have them all in thirds. My last one is 2/3. My other ones are all filled in because I have all 3 of them. This is 1 hole, this is 2 holes, this is 3 holes, and then this is 2/3. So now I can see, okay, how many pieces do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So once again, I have 3, 6, 9, and then get to 11 when I add those extra 2 pieces. If I had 4 holes, that would be 12, because 12 divided by 3 equals 4. So that's how I look at those mixed numbers turning into improper fractions. Now, if I had an improper fraction and I were trying to turn it into a mixed number, then I can use whatever pictures I want to as well. So let's say I had 15/4. Let's try that. So one thing I could do is make a bunch of circles that are all split into fourths. I don't know how many circles I'm going to need yet, so I'm just drawing a bunch. And I split them all into fourths. Now I'm going to count up my 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There I go. So I have 1, 2, 3 holes and 3/4 left over. So my answer is 3 3/4 to convert from that improper fraction to a mixed number. I could also use fraction bars again. So I can think about, here's 1 hole, here's another hole, here's another hole, here's another hole, and I am just going to split them all into fourths and think I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that leaves me with 3/4 at the end and 1, 2, 3 holes. If I didn't want to draw a whole picture, but I still wanted some visual for myself, I could also just do dots. So I can just do 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15. And then I just make groups of 4. So I have a group of 4. Okay, that's 1. I have a group of 4. Okay, that's 2. I have a group of 4. That's 3. Oh, I only have 3. So that's going to be 3 out of 4 that I have. So I can just draw little dots. And that goes really fast too. If I weren't quite sure. I can also think about this as a division problem and divide. So I could do 15 divided by 4, and I think 4 goes into 15 3 times. I get 12. I have 3 left over, so I have remainder 3, which I know is the same as 3 out of the 4. If I kept dividing though, then I would get 4 into 30, which equals 7, 28. I have 2 left over. I bring it down, and that's 5. 5 times 4 is 20. And I have 0 left over now. So 3.75 is 3 3/4. So those sorts of things also work when I'm using any kind of long division. And I could type this into a calculator, and then I just need to know that 0.75 means 3/4. When I'm thinking about equal fractions, I talked about this in the proportions video a lot, is that all I'm doing is I'm making sure that I'm multiplying to get equal fractions. So if I have 2/3 and I knew that that equaled 4/6. The way I'm getting there is by multiplying both the numerator and the denominator by the same number. So 2 times 2 equals 4, 3 times 2 equals 6. If I think about this only as adding or subtracting, remember that does not work. So 2 plus 2 to 4, 3 plus 2 equals 5. That doesn't work. And I can also cross multiply to check that they equal each other. So 2 times 6 equals 12, and 3 times 4 equals 12. So 12 equals 12, that means that they're equal if I can cross multiply and get the same number. So that's another way that I can check for equal fractions.